I've been a lecturer in civil engineering here since 2001, with the exception of 1 year. I took a year's leave of absence in the 04-05 academic year to work with a UK-based contractor, with the view to getting some experience and also to develop some research links. I suppose the area within civil engineering that I am responsible for is called geotechnics or geotechnical engineering, which is concerned with the role of soil in supporting structures. So things like foundations for buildings, road embankments, tunnels, retaining walls, and so on. So I teach on 2 modules. One is a 3rd year soil mechanics module, which is taken by students in the BE civil engineering, environmental engineering, energy systems engineering, and project and construction management. And then in 4th year I teach geotechnical engineering to the civil and environmental engineers. And in addition, I am supervisor for 4 PhD students and a master's student. I think the biggest challenges I face are associated with my subject area. So just the nature of soil. For example, with steel as a material, it's a man-made material and its properties are well understood. So if you want to design a steel or concrete, a steel beam or column, you just go to a manual and you have exact properties which you can use. With soil, it's a natural material, so it varies considerably, even on one site and with depth. And then there's the additional complication that it's not just soil particles, there's water and air in there, which makes the mechanics a lot more complicated. And a third element is the fact that what happened to that soil in the past is highly relevant to how it behaves today. So, for example, glacial till, which is a material that you have in the east of the country, at some point was under 1 kilometre of ice. So that's going to behave quite differently to a silt that's deposited at the Shannon estuary. So the challenges I find are related to the subject itself, and it's generally perceived to be one of the more difficult subjects in the civil engineering programme. I introduced a new project last year, an inquiry-based learning project based around embankments that were built in the run-up on the approach to the Limerick Tunnel. And I suppose with a lot of problems that I would give them, they would have there'd be textbook problems with just defined parameters. Whereas for this particular project, there's a huge scatter of data that's being collated. And one of the roles of the engineer is to try and assess how to use that data. What values should be used. So I introduced this and give them exposure to this, I suppose, scatter of data that they have to interpret. And as well as that, I don't really give them much guidance on how to work out the settlement beneath this embankment. They have covered the theory, but they've got to work out themselves, how to apply it. And I think certainly for the first week or 2 they find this very challenging, but once they get into it, I think they enjoy it. And I think in the longer term they have, I suppose, the theory that they've learned sticks when they have seen an application of it. I've been using Blackboard quizzes probably for about 6 or 7 years, but when I started out I used the multiple choice or multiple answer questions, which were convenient for me to set up, but what I found was that because all students were getting exactly the same questions, that they started to copy. They mightn't have in the first assignment, but they copped on after the 2nd or 3rd. So what I have done to avoid that is I've used a style of question called formula style. So if you've got a problem that can be answered by a formula, then you can put the formula into Blackboard, and for each of the variables in the formula you can assign a range of values, so that each student, while they may get the same basic problem, there could be 4 or 5 different values in the problem that they have to use, and they all get different answers. And I found that has cut back a lot on plagiarism. As well as that, there's also you can use pools, so you can develop question banks of pools on one particular topic, and I can draw at random from those pools, so again to mix things up a bit. And since I've done that, I found that the marks that students get in these quizzes actually has reduced, but I think the mark in the exam has probably gone up slightly. One area that I use quite a bit in geotechnics is case histories, and including failures, dramatic failures, because they generally capture students' imagination. I suppose we all know about the Leaning Tower of Pisa, but again, there are a few very simple learning outcomes that can be taken from that. There are other ones as well. There's a landslide which took place in Norway back in 1978 in a place called Rissa near Trondheim, which is very dramatic. And there are a number of separate learning outcomes that can be tied together with that one video, which is available now on YouTube. And there are several others. There's a grain elevator which collapsed in Canada back in 1913. And what was unusual about it was the collapse actually prompted the development of what's called bearing capacity theory. So the mechanics of how buildings were supported by soil wasn't understood until this building collapsed. And then engineers started looking at how the ground had moved underneath this building. It was a rotational slip. And then started taking soil samples and testing, and then 20 years later a theory developed from it. So that's unusual. I suppose soil mechanics as a subject area is really only about 100 years old. I think one thing that's improved my teaching and improved the teaching of a lot of my colleagues is the environment of the new building. I think it's just much more conducive to good teaching than where we had been. Just simple things like being able to pull a whiteboard over what you have projected onto the screen and superimpose your own writing on it. Simple things like that make a big difference. I guess probably like a lot of lecturers, when I started out, my first few years was just concerned with my own delivery. And then I realised that, well, actually, there's more to it than this. And the problems the students were having weren't being solved by my improved delivery. So I suppose I started to focus more on the problems they were having. And sometimes you can be quite surprised what they come back with. What I think their problems are quite different to what they have difficulties with. So I enjoy that, enjoy the interaction with them. Absolutely delighted to receive it. I think I was on a high for a couple of weeks afterwards. It was back in July, I organised an international conference on geotechnical education here in NUI Galway, and I guess up until about April or May I was very busy getting the papers reviewed, and then when the final papers were ready, getting them to the publishers. But there was probably a spell of about 2 or 3 weeks in early June where the pressure was off, because there were some things I couldn't really do until the last week of June, early July was the conference. And that's when I got word of the teaching award. So it came at a great time. I was delighted and grateful to the students for nominating me and for the support of my colleagues as well. I'd like to do some work on flip learning. Catherine Cronin gave a presentation at one of our college meetings probably back in February or March, and she was talking about the move to online learning, and flip learning captured my imagination. So what I'd like to do in the coming academic year is to try it out with my third year soil mechanics module. And what I'm thinking of doing at the moment, with the view to trying to find out how effective it is, to maybe teach half of it through flip learning. So to develop resources, video resources for half of the module, and then do examples in the lecture time, and then deliver the other half using traditional means and get student feedback and my own perceptions of how well it has gone.